The Boötes Void, the biggest hole in the universe. A region so impossibly empty, so staggeringly vast, that if you were born inside it, you would have believed for your entire life that the universe contained nothing but darkness. No distant lights, no neighboring worlds, no evidence that anything else existed at all. Just you floating alone in an ocean of nothing that stretches for hundreds of millions of light years in every direction. This is not science fiction. This is not some far-off dream of what might exist beyond our reach. This is reality. This is a place that exists right now, hidden in plain sight among the stars we see every night. And yet most people have never heard of it. Most people have no idea that the universe contains a hole so large, so impossibly empty, that it challenges everything we thought we understood about how the cosmos works. Tonight, we are going to take a journey into the heart of this cosmic mystery. We are going to explore a place where the rules seem to break down, where the expected gives way to the impossible, where the very fabric of space and time appears to have been stretched thin until almost nothing remains. But before we can understand what the Boötes Void is, we need to understand what should be there. We need to understand why its emptiness is so shocking, so unexpected, so deeply strange. Because the universe, you see, is not supposed to have holes like this. The universe is supposed to be full. Let us start at the beginning. Not the beginning of time itself, but the beginning of our story. The moment when a team of scientists stumbled upon something that would change our understanding of the cosmos forever. It was 1981. Ronald Reagan had just become president. The first space shuttle had just launched. IBM had just released its first personal computer. And in a quiet observatory far from the noise and bustle of everyday life, an astronomer named Robert Kirshner was doing something remarkably simple. He was counting galaxies. Not literally counting them one by one, of course. What Kirshner and his team were doing was conducting what scientists call a redshift survey. They were measuring how fast different galaxies were moving away from us, and using that information to figure out how far away those galaxies actually were. It was painstaking work, tedious work, the kind of work that requires patience and precision, and countless hours staring at data. But this kind of work is also the backbone of our understanding of the universe. By measuring the redshift of thousands of galaxies, astronomers could build a three-dimensional map of the cosmos. They could see not just where galaxies appeared in the sky, but how far away they actually were. They could see the true structure of the universe in 3 dimensions for the very first time. And what they expected to see was pretty straightforward. They expected to see galaxies scattered more or less evenly throughout space, like sprinkles on a cosmic cake. Sure, there would be some clumping here and there. Galaxies tend to gather in groups and clusters pulled together by gravity. But overall, they expected the distribution to be fairly uniform. That was what their theories predicted. That was what should have been there. Instead, they found a hole. As Kirshner and his team plotted their data, they noticed something strange. There was a region of space where their instruments were returning almost nothing. Not just fewer galaxies than expected, but almost no galaxies at all. At first, they assumed there must be a mistake. Maybe their equipment was malfunctioning, maybe there was dust or gas blocking their view, maybe they had simply miscounted. But the more they looked, the more certain they became. The hole was real, and it was enormous. What they had discovered was a roughly spherical region of space, centered about 700 million light-years from Earth, that contained almost nothing. While the surrounding regions of the universe were packed with galaxies by the thousands, this region held only a handful. Where there should have been 2,000 galaxies, there were barely 60. And those 60 were not even scattered throughout the void. They were clustered in a strange tube-shaped region running through the middle, as if they were the last survivors clinging to a cosmic lifeline. The scientists named their discovery after the constellation where it appeared to be located. They called it the Boötes Void, after Boötes the herdsman, that ancient star pattern that guards the northern sky. Some astronomers, struck by the sheer emptiness of what they had found, began calling it by another name, the Great Nothing. Now, to truly grasp why this discovery was so shocking, you need to understand just how big this void actually is. And I want to warn you right now, the numbers we are about to discuss are going to be difficult to comprehend. They're going to push against the limits of human imagination. because we are talking about scales so vast, so mind-bendingly enormous, that our everyday experiences give us nothing to compare them to. The Boötes Void has a diameter of roughly 330 million light-years. Let that sink in for a moment. 330 million light-years. A light-year, remember, is the distance that light travels in 1 year. Light moves at about 186,000 miles per second. In 1 year, traveling at that unimaginable speed, light covers about 6 trillion miles. And the Boötes Void stretches for 330 million of those light years. But numbers like these are almost meaningless to the human mind. So let us try to put this in perspective a different way. Our home galaxy, the Milky Way, is about 100,000 light years across. It contains somewhere between 100 billion and 400 billion stars. It is home to our solar system, our Earth, everything we have ever known. And the Boötes Void could swallow over 3,000 Milky Way galaxies, placed edge to edge, and still have room to spare. Or think about it this way. The nearest major galaxy to us, the Andromeda Galaxy, is about 2.5 million light-years away. That is considered close in cosmic terms. We can see Andromeda with our naked eyes on a dark night. But if you were to take the distance from the Milky Way to Andromeda and multiply it by 130, you still would not span the entire width of the Boötes Void. Here is perhaps the most striking way to understand the vastness of this cosmic emptiness. Astronomer Greg Aldering, who spent years studying this region, once made a remarkable observation. He said that if our Milky Way galaxy had been located in the center of the Boötes Void instead of where it actually is, we would not have discovered that other galaxies existed until the 1960s. Think about what that means. All of human history, all of our gazing at the stars, all of our wondering about what lay beyond, would have taken place in complete cosmic isolation. Galileo would have looked through his telescope and seen nothing but darkness. Newton would have formulated his laws of gravity without any distant objects to test them against. Hubble would never have made his famous discovery that the universe was expanding, because there would have been no other galaxies close enough to measure. We would have believed, right up until the development of our most powerful modern telescopes, that our galaxy was all that existed, that we were truly alone in an infinite sea of nothing. This is the scale of emptiness we are dealing with. This is the magnitude of the great nothing. But size alone is not what makes the Boötes Void so mysterious. What truly puzzles scientists is how such a vast region of emptiness could exist at all. Because according to our best understanding of how the universe works, voids like this should not be possible. To understand why, we need to go back to the very beginning of time. We need to go back to the moment of creation itself. The Big Bang. Nearly 14 billion years ago, our universe exploded into existence from a point of infinite density and temperature. In the first fraction of a second, all the matter and energy that would ever exist came into being. And crucially, that matter was not perfectly evenly distributed. There were tiny, almost imperceptible variations in density. Some regions had slightly more matter than others. Some regions had slightly less. These tiny variations, smaller than 1 part in 100,000, would turn out to be the seeds of everything we see today. Because gravity, that fundamental force that pulls all matter together, began to work on these variations immediately. Regions with slightly more matter exerted slightly more gravitational pull. They attracted more matter from their surroundings. Regions with slightly less matter exerted less pull and found themselves losing material to their denser neighbors. Over millions and billions of years, this process continued. The rich got richer, the poor got poorer, dense regions grew denser and eventually collapsed into stars and galaxies. Empty regions grew emptier as their matter was stripped away. The result, after 14 billion years of cosmic evolution, is what scientists call the cosmic web. This is the large-scale structure of the universe, and it is one of the most beautiful and awe-inspiring things that astronomy has ever revealed. Imagine a three-dimensional spider web, but one that stretches for billions of light years in every direction. The threads of this web are filaments, long strands of galaxies stretched out like strings of cosmic pearls. Where filaments meet, you find clusters and superclusters, dense knots of thousands of galaxies packed together in gravitational embrace. And between the filaments, filling the spaces in the web, are voids, regions of relative emptiness where few galaxies dare to tread. This structure is not random. It is the inevitable result of gravity working on those primordial density variations over cosmic time. Computer simulations that model the evolution of the universe from the Big Bang to the present day consistently produce this same web-like structure. Filaments, clusters, and voids all intertwined in a cosmic dance that has been playing out for nearly 14 billion years. But here's the thing. Those same computer simulations predict how big the voids should be. And while voids are expected, massive voids spanning hundreds of millions of light years are not supposed to form. The universe simply has not had enough time. The gravitational processes that create voids work slowly over billions of years, and 330 million light years of nearly perfect emptiness should be beyond what those processes can achieve in the age of our universe. The Boötes Void, in other words, should not exist, and yet there it is, a hole in the fabric of the cosmos, staring back at us, challenging us to explain its existence. Scientists have proposed several theories to account for this impossibly large void. Each theory offers a different window into the mysteries of cosmic evolution. Each theory raises as many questions as it answers. The most popular explanation is what we might call the bubble merger theory. Remember how voids form in the cosmic web? Dense regions pull matter away from less dense regions, creating pockets of emptiness. Well, what if multiple voids formed close to each other and then merged over time? Just like soap bubbles in a bath can merge to form larger bubbles, cosmic voids might merge to form supervoids. According to this theory, the Boötes Void did not form as a single massive void. Instead, it started as several smaller voids, each one perfectly normal and well within the predictions of our cosmological models. Over billions of years, these voids grew larger and eventually merged together, their walls dissolving as they combined into a single, enormous region of emptiness. This would explain the strange, tube-shaped region of galaxies running through the middle of the void. Those 60 or so galaxies that we find inside the Boötes Void are not scattered randomly. They are clustered along a line, like beads on a string. The bubble merger theory suggests that these galaxies are the remnants of the walls between the original smaller voids. When the voids merged, most of their walls dissolved. But this one central filament survived, a cosmic scar marking where separate bubbles once met. It is an elegant theory. It fits with what we know about how the universe evolves. But it does not fully explain everything. Even if we accept that multiple voids merged to create the Boötes Void, we still need to explain why so many voids formed in the same region to begin with. Was it just random chance, or was there something special about this region of space from the very beginning? Some scientists have suggested a more radical possibility. What if the Boötes Void is not the result of normal cosmic evolution at all? What if it is a relic, a leftover from the very earliest moments of the universe? This idea goes back to those primordial density variations we discussed earlier. In the standard cosmological model, those variations were random. They followed a statistical pattern, but there was no special significance to any particular region. The seeds of galaxies and voids were scattered across the early universe without any preferential structure. But what if that is not quite right? What if, for some reason, the region of space that would become the Boötes Void started out with an unusually large deficit of matter? What if, from the very first moments after the Big Bang, this region was destined to become a void of extraordinary size? This would not require any new physics. It would simply be a matter of probability. In a universe with random variations, some regions will inevitably be more extreme than others. The Boötes Void might just be one of those statistical outliers, a region that happened to start with such a pronounced deficit that it grew into a supervoid far larger than average. Think of it like flipping a coin. Most of the time, if you flip a coin 1,000 times, you will get something close to 500 heads and 500 tails. But occasionally, just by random chance, you might get 600 heads or 400 heads. The Boötes Void might be the cosmic equivalent of an unusually long streak of tails. Rare, unexpected, but not impossible. Of course, there is no way to directly observe what the early universe looked like in the specific region that would become the Boötes Void. We cannot travel back in time, we cannot rewind the cosmic clock. But scientists can test this idea indirectly by looking at the cosmic microwave background radiation. This ancient light, released when the universe was only 380,000 years old, carries an imprint of those primordial density variations. If the Boötes Void region was unusually empty from the very beginning, there might be a corresponding cold spot in the microwave background. Astronomers have searched for such a cold spot, and the results are intriguing but inconclusive. There are hints of unusual features in the microwave background in the direction of the Boötes Void, but nothing definitive enough to prove that the void was predetermined from the moment of creation. The mystery remains. And then there is a third possibility, one that ventures into more speculative territory. What if the Boötes Void is not just a product of gravity and cosmic evolution? What if it is evidence of something we have not yet discovered, something that lies beyond our current understanding of physics? This idea takes many forms. Some scientists have wondered whether the Boötes Void could be influenced by dark energy, that mysterious force that is causing the expansion of the universe to accelerate. Dark energy pushes space apart, and its effects are strongest in regions where there is little matter to resist it. In the emptiness of a void, dark energy would have free rein. Could it have pushed the Boötes Void to grow faster and larger than normal physics would allow? Others have speculated about even stranger possibilities. Could the Boötes Void be the signature of some exotic physics from the early universe? Could it be related to cosmic strings, those hypothetical defects in the fabric of space-time that some theories predict? Could it even be evidence of something beyond our universe entirely, a sign that our cosmos was influenced by neighboring universes in a vast multiverse? These ideas are highly speculative. They're at the very edge of what science can currently address, but they illustrate an important point. The Boötes Void is not just a curiosity, not just an interesting feature on the map of the cosmos. It is a challenge. It pushes against the boundaries of our knowledge and forces us to ask whether our understanding of the universe is complete. Let us step back from these grand theoretical questions for a moment and consider something more personal. Let us consider what it would actually be like to live inside the Boötes Void. Imagine that your civilization arose not in the Milky Way, not in a crowded corner of the cosmic web surrounded by billions of neighboring galaxies, but in one of those 60 lonely galaxies floating in the great nothing. What would your night sky look like? What would your understanding of the universe be? The answer is both beautiful and deeply unsettling. If you were born in the center of the Boötes Void, your night sky would be almost completely dark. Oh, you would see the stars of your own galaxy, of course. Those billions of suns would still blaze across your heavens, forming familiar patterns that your poets and navigators would name and celebrate. But beyond your galaxy, there would be nothing. No faint smudges of light hinting at distant island universes. No Andromeda spanning the sky like a ghostly spiral. No Magellanic clouds trailing behind like cosmic companions. Your astronomers, as they developed better and better telescopes, would search in vain for other galaxies. They would scan the heavens and find only darkness. For generation after generation, your brightest minds would puzzle over a fundamental question. Is our galaxy alone? Is this all there is? And they would have no answer, because the nearest galaxies would be so far away, hundreds of millions of light years distant, that even with telescopes of extraordinary power, they would be almost impossible to detect. The light from those distant galaxies would be so faint, so red shifted, so obscured by the vast emptiness between, that your civilization might advance for thousands or even millions of years without ever knowing that the universe extended beyond your own island home. Think about how that would shape your understanding of reality. Think about how it would shape your philosophy, your religion, your sense of place in the cosmos. In our universe, the discovery of other galaxies was one of the most profound moments in human history. When Edwin Hubble proved in the 1920s that Andromeda was a galaxy separate from our own, he changed everything. Suddenly, our Milky Way was not the entire universe. It was just one galaxy among billions. We were smaller than we had ever imagined, but we were also part of something far grander. A civilization in the Boötes Void would never have that moment of revelation. They would never experience that humbling expansion of perspective. They would grow up believing they were alone, and for all practical purposes, they would be right. Or would they? Here's where the story takes an even stranger turn, because the galaxies inside the Boötes Void are not quite like the galaxies we are familiar with. They have evolved in isolation, cut off from the cosmic community, and that isolation has left its mark. In the crowded regions of the universe, galaxies interact constantly. They crash into each other, merge, tear each other apart with gravitational forces. These interactions drive evolution. They trigger bursts of star formation. They shape galaxies into the forms we see today, the graceful spirals and smooth ellipticals that populate our cosmic neighborhood. But in the Boötes Void, there are no neighbors to interact with. The galaxies there have evolved in peace, untouched by the cosmic violence that shapes galaxies elsewhere. They are pristine, preserved like fossils from an earlier era of cosmic history. Scientists call these void galaxies, and they are fascinating objects of study. They tend to be smaller and less massive than galaxies in denser regions. They often retain large amounts of hydrogen gas, the raw material for star formation, because there are no neighbors to strip that gas away. And they sometimes develop unusual shapes, extended and irregular, because there is no gravitational pressure from the cosmic environment to squeeze them into more compact forms. In a sense, the galaxies of the Boötes Void offer a window into what galaxy evolution looks like without outside interference. They are laboratories for understanding the internal processes that shape galaxies, separate from the environmental factors that dominate elsewhere. By studying them, astronomers can disentangle the various forces that determine how galaxies grow and change over cosmic time. One of the most isolated galaxies ever discovered lives within the Boötes Void. Its name is MCG plus 01 minus 02 minus 015, a string of numbers that reflects its position in astronomical catalogs rather than any poetic inspiration. But what it lacks in a memorable name, it makes up for in sheer loneliness. This galaxy, captured in stunning detail by the Hubble Space Telescope, is a beautiful spiral, its arms curving gracefully around a bright central core. It looks almost exactly like what you would imagine a perfect galaxy to look like, and that is precisely what makes it so interesting. Spiral galaxies like MCG plus 01 minus 02 minus 015 are thought to be shaped by gravitational interactions. The arms form and reform as the galaxy rotates and as it encounters other galaxies. In crowded environments, these interactions are frequent, and spirals tend to be disturbed, lopsided, asymmetrical. But this galaxy is symmetrical. It is pristine. It has had no neighbors to disturb it, possibly for billions of years. And yet it still looks like a classic spiral galaxy. This suggests that spiral structure can arise and be maintained even without external interactions, a finding that has implications for our understanding of how galaxies work. Or did this galaxy somehow end up in the void after forming elsewhere? Was it flung into the great nothing by some ancient gravitational encounter, then left to drift alone for eons? We do not know for certain. The origins of the galaxies within the Boötes Void remain as mysterious as the void itself. What we do know is that these galaxies are survivors. They have endured in an environment where almost nothing else exists. They are the last lights in a sea of darkness, burning their hydrogen fuel and forming new stars, with no one to witness their brilliance but each other. And speaking of darkness, let us talk about what actually fills the Boötes Void, because empty is a relative term when it comes to space. When we say the Boötes Void is empty, we do not mean it contains literally nothing. Even the emptiest reaches of intergalactic space are not truly empty. There are always some particles, some radiation, some remnants of cosmic history drifting through the darkness. In an average region of space, you might find about 1 particle per cubic meter. That is unimaginably sparse by everyday standards. The air you are breathing right now contains about 25 billion molecules per cubic meter. Space is empty beyond anything we encounter in our daily lives. But the Boötes Void is even emptier. Its central regions may contain only a tiny fraction of the particles found in typical intergalactic space. Some estimates suggest that the deepest parts of the void might have particle densities several times lower than the cosmic average. This makes the Boötes Void not just empty of galaxies, but empty of almost everything. This extraordinary emptiness has some interesting consequences. Think about what happens when you shine a light through a medium. The light interacts with the particles in that medium. It can be absorbed, scattered, redirected. Even in the near vacuum of intergalactic space, photons traveling for hundreds of millions of years will occasionally bump into something. But in the Boötes Void, those interactions are even rarer. A photon could travel through the void for 300 million years and barely encounter anything at all. The void is essentially transparent, a window through the universe where nothing interferes with the passage of light. This transparency makes the Boötes Void a kind of cosmic time capsule. Photons from the early universe, from the cosmic microwave background, pass through the void almost unchanged. They carry information about the conditions of the early cosmos that has been preserved with extraordinary fidelity. In a sense, looking through the Boötes Void is like looking through a clear lens, one that offers an unusually pure view of what lies beyond. But this same emptiness creates challenges for scientists trying to study the void. How do you map something that is defined by what it lacks? How do you measure the boundaries of nothing? The answer lies in looking not at the void itself, but at what surrounds it. The Boötes Void is bordered by some of the most impressive structures in the nearby universe. It is surrounded by a ring of superclusters, vast congregations of galaxies that mark the edges of the emptiness. To the north lies the Ursa Major supercluster, to the south the Corona Borealis supercluster. The famous Hercules supercluster marks another boundary, while the Boötes supercluster itself forms part of the wall. These structures are dense with galaxies, rich with cosmic activity, vibrant with the light of trillions of stars, and together they define the shape of the void between them. Scientists map voids by mapping these walls. They conduct redshift surveys, measuring the distances to thousands of galaxies, and then look for the gaps. Where the galaxies stop, where the maps go dark, that is where the void begins. This technique has revealed not just the Boötes Void, but a whole population of cosmic voids scattered throughout the universe. Some are small, just a few tens of millions of light years across. Others are larger, spanning hundreds of millions of light years. The Boötes Void is among the largest, but it is not unique. The universe is full of holes. In fact, when astronomers stepped back and looked at the big picture, they discovered something remarkable. Voids are not just occasional features of the cosmic landscape. They are the dominant feature. By volume, approximately 80% of the universe is void. The galaxies and clusters and superclusters that seem so prominent to us are actually a minority. They are the thin walls separating vast bubbles of emptiness. Our own Milky Way sits near the edge of a void called the local void, or sometimes the KBC void, after the scientists who mapped it. This void is not as dramatic as the Boötes Void, but it still stretches for hundreds of millions of light years. We are, in a very real sense, living on the edge of a cosmic desert. This realization has profound implications for how we understand the structure of the universe. The cosmos is not filled with galaxies, it is filled with emptiness, punctuated by galaxies. The bright lights that captured our attention, the spiral arms and glowing nebulae and star-forming regions that populate our astronomical images, are the exception rather than the rule. And this emptiness is not static, it is growing. Here is where the story of the Boötes Void connects to one of the deepest mysteries in all of physics, the mystery of dark energy. In the late 1990s, two teams of astronomers made a discovery that shook the foundations of cosmology. They were studying distant supernovae, massive stellar explosions that can be seen across billions of light years. By measuring how bright these supernovae appeared compared to how bright they should have been, the astronomers could calculate how far away they were and how fast the universe was expanding at different points in cosmic history. What they expected to find was that the expansion of the universe was slowing down. After all, gravity pulls things together. Every galaxy in the universe is gravitationally attracted to every other galaxy. Over time, this mutual attraction should act like a brake, gradually slowing the cosmic expansion that began with the Big Bang. Instead, they found the opposite. The expansion of the universe is not slowing down, it is speeding up. Some mysterious force, is pushing the cosmos apart faster and faster with every passing moment. Scientists name this force dark energy, and despite decades of research, we still have no idea what it actually is. We know that it makes up about 68% of the total energy content of the universe. We know that it acts like a kind of anti-gravity, pushing space apart rather than pulling it together. But beyond that, dark energy remains one of the greatest unsolved puzzles in physics. And here is where voids become important. Because the effects of dark energy are not uniform throughout the universe. In regions with lots of matter, gravity can overwhelm dark energy. The gravitational attraction between galaxies in a cluster, for example, is strong enough to hold them together despite the push of dark energy. But in voids, there is almost no matter. There's almost no gravity. And in these empty regions, dark energy reigns supreme. Think of it this way. In the dense parts of the universe, gravity and dark energy are locked in a tug of war. Gravity pulls things together. Dark energy pushes them apart. In most places, these forces are nearly balanced, with gravity having a slight edge thanks to the matter that is present. But in voids, the tug of war is lopsided. There is almost no matter to provide gravitational pull, so dark energy wins easily. The void expands, it grows, it pushes on the walls of galaxies that surround it, forcing them apart. The Boötes Void is one of the largest arenas where this process is playing out. With its extraordinarily low density, dark energy has almost free reign within its boundaries. The void is growing, stretching, pushing against the superclusters that surround it. And it is not alone. Every void in the universe is undergoing the same process. They are all expanding, all pressing outward, all slowly dissolving the cosmic web. Some scientists have calculated what this means for the future of the universe. In 10 to 20 billion years, the voids will win. The filaments that connect galaxies will thin and break. The walls that separate voids will dissolve. The cosmic web, that beautiful structure that took 14 billion years to form, will fade away. What will be left is a universe of isolated island galaxies, separated by distances so vast that they can no longer see or influence each other. Each galaxy will drift, alone through an infinite sea of darkness, its light unable to reach any other shore. The universe will become a collection of lonely outposts cut off from one another forever. In a sense, the Boötes Void is a preview of this future. It shows us what large swaths of the universe will eventually look like. The emptiness that seems so exceptional today will become the norm tomorrow. But we are getting ahead of ourselves. Before we contemplate the fate of the universe, let us return to the present and consider how scientists are continuing to study the Boötes Void. Modern astronomy has tools that Robert Kirshner and his colleagues in 1981 could only dream of. Telescopes in space, free from the blurring effects of Earth's atmosphere, can see fainter and farther than ever before. Massive surveys are mapping millions of galaxies, building three-dimensional models of the cosmic web with unprecedented detail. And powerful computer simulations can model the evolution of the universe from the Big Bang to the present day, testing our theories against the structures we observe. One of the most exciting recent developments is the use of gravitational lensing to study voids. According to Einstein's theory of general relativity, massive objects bend the fabric of space-time, and this bending affects the path of light passing nearby. We usually think of this effect in the context of massive galaxies or clusters, where the light from more distant objects gets bent and distorted into arcs and rings. But the opposite effect also occurs. In regions of low density, like voids, space-time is less curved. Light passing through a void follows a slightly different path than light passing through a denser region. By carefully measuring these differences, astronomers can map the distribution of matter in the universe, including the matter that we cannot see directly. This technique has revealed that voids are not just empty of visible galaxies, they are also deficient in dark matter. This mysterious substance, which makes up about 27% of the universe's energy content, does not emit or absorb light. We can only detect it through its gravitational effects. And gravitational lensing studies show that the Boötes Void and other voids have less dark matter than average regions of space. This makes sense in the context of cosmic evolution. Dark matter, like ordinary matter, was subject to those primordial density variations. It clumped together in dense regions and evacuated from less dense regions. The voids we see today are empty not just of galaxies, but of the invisible scaffolding on which galaxies form. Another powerful tool for studying voids is the cosmic microwave background. This ancient radiation, released when the universe was only 380,000 years old, provides a snapshot of the cosmos before galaxies existed. By studying the tiny variations in temperature across the microwave background, scientists can learn about the density fluctuations that seeded all of cosmic structure. When light from the cosmic microwave background passes through a void, it undergoes a subtle change. The void, because it contains less matter, has a slightly different gravitational environment than denser regions. Photons traveling through the void gain a tiny amount of energy as they enter, but lose energy as they exit. Because the void is expanding, the universe has grown slightly during the photon's transit, and the photon ends up losing slightly more energy than it gained. The net result is that the photon is slightly cooler when it emerges from the void. This effect, called the integrated Sachs-Wolf effect, allows astronomers to find voids by looking for cold spots in the cosmic microwave background. And sure enough, there is a hint of a cold spot in the direction of the Boötes Void. The signal is subtle and difficult to measure precisely, but it provides independent confirmation that the void is real and not just an artifact of how galaxies are distributed. The James Webb Space Telescope, launched in 2021, is opening new windows on the study of voids. With its extraordinary sensitivity to infrared light, Webb can detect galaxies that are too faint or too distant for other telescopes to see. This capability is particularly valuable for studying voids, where the galaxies are sparse and often small. Early observations from Webb have already revealed previously unknown dwarf galaxies in underdense regions of the universe. These tiny galaxies, containing only millions or billions of stars compared to the hundreds of billions in the Milky Way, are important for understanding how structure forms in low-density environments. As Webb continues its observations, we can expect to learn much more about the population of galaxies that inhabit the cosmic voids. Future surveys promise even greater advances. The Vera C. Rubin Observatory, currently under construction in Chile, will conduct a decade-long survey of the southern sky, mapping billions of galaxies and creating the most detailed three-dimensional model of the universe ever assembled. The Euclid Space Telescope, launched by the European Space Agency, is specifically designed to study dark energy and dark matter, and voids will be a key target of its observations. These projects will help answer some of the fundamental questions that the Boötes Void raises. How did such large voids form? Are they consistent with our standard model of cosmology, or do they hint at new physics? What can the properties of voids tell us about dark energy and the fate of the universe? But beyond the science, the Boötes Void invites us to reflect on something more personal. It invites us to contemplate our place in the cosmos. We live in a remarkably fortunate location. Our Milky Way galaxy sits in a region of the universe that is neither too crowded nor too empty. We have neighboring galaxies close enough to see and study, but not so close that they threaten to collide with us anytime soon. We are part of a cosmic community, connected by gravity and light to billions of other worlds. The hypothetical beings living in the center of the Boötes Void would have no such luxury. They would be cosmic orphans, cut off from the wider universe, alone in a way that we can barely imagine. And yet, from a certain perspective, even we are alone. The nearest star to our sun is over 4 light-years away. The nearest galaxy is over 2 million light-years distant. On human timescales, these distances are effectively infinite. We cannot visit them, cannot touch them, cannot interact with them in any meaningful way. We are separated from the rest of the cosmos by gulfs of space that our technology cannot bridge. The Boötes Void just takes this isolation to its logical extreme. It shows us what cosmic loneliness truly looks like. And in doing so, it helps us appreciate how connected we actually are. There is something deeply humbling about contemplating the great nothing. Humbling, but also awe-inspiring. Because the same universe that produced this vast emptiness also produced us. The same physical laws that created a void 300 million light-years across also created carbon atoms and DNA molecules, and human brains capable of wondering about the cosmos. We are, in the words of astronomer Carl Sagan, a way for the universe to know itself. And part of knowing the universe is coming to terms with its emptiness. Coming to terms with the fact that most of the cosmos contains nothing at all. Let us now turn to one of the most intriguing questions that the Boötes Void raises, a question that takes us from the realm of established science into the realm of speculation and imagination. Could the Boötes Void or any cosmic void harbor life? At first glance, the answer seems obviously no. Life, as we understand it, requires matter. It requires planets orbiting stars. It requires chemistry and complexity and the raw materials from which living things can be built. The center of the Boötes Void, with its extraordinarily low particle density, seems like the last place in the universe where life could arise. But the Boötes Void is not completely empty. Those 60 galaxies are still there, scattered along that strange tube-shaped region through the middle. Each of those galaxies contains billions of stars. Each of those stars could potentially have planets. And some of those planets just might support life. If there are intelligent beings living within the Boötes Void, their experience of the universe would be radically different from ours. Their scientists would face a much harder challenge in discovering the true nature of the cosmos. Remember, if the Milky Way were in the center of the Boötes Void, we would not have known other galaxies existed until the 1960s. For a civilization starting from scratch, the journey from basic astronomy to the discovery of extragalactic objects would be immensely more difficult. They would have to develop telescopes of extraordinary power just to see the faintest hints of galaxies hundreds of millions of light years away. But more than that, their understanding of cosmology would be skewed. The cosmic microwave background, that ancient radiation from the early universe, would still be there. They could still detect the Big Bang. But the distribution of galaxies, the cosmic web, the large-scale structure that tells us so much about how the universe evolved, would be invisible to them. They would know the universe began in a hot, dense state, but they might have no idea what it actually looks like today. Would they conclude that they were alone? Would they believe that their galaxy was the only structure in an otherwise empty cosmos? Or would they, through sheer persistence and ingenuity, eventually discover the faint glow of distant superclusters at the edge of their observable universe? We cannot know. But the question itself reveals something profound about the relationship between our location in the universe and our understanding of it. We are not just observers of the cosmos, we are participants, embedded in a particular place and time, with a view shaped by our circumstances. The beings of the Boötes Void, if they exist, would have a fundamentally different perspective. Their cosmology would be shaped by their isolation. Their sense of the universe would be colored by the vast emptiness surrounding them. And here's the truly strange thing. They might actually be more scientifically accurate than we are, at least in one respect. Remember, the universe is mostly void. 80% of its volume is emptiness. We live in the 20% that is dense enough to form stars and galaxies. In a statistical sense, we are the outliers. We are the exception. A civilization in the Boötes Void would have a more representative view of what the universe actually is. They would grow up surrounded by emptiness, and emptiness is what the universe mostly is. Our crowded corner of the cosmos, with its web of filaments and clusters, might seem like the anomaly from their perspective. Of course, there is something to be said for living in an anomaly. Our location in a relatively dense region of the universe has given us access to tremendous amounts of information about cosmic structure and evolution. We can study other galaxies, map the distribution of matter, trace the history of the cosmos. A civilization in the void would have far less to work with, but perhaps they would have developed their science in different directions. Perhaps lacking external objects to study, they would have turned inward. They might have advanced further in fields like particle physics or quantum mechanics, studying the fundamental nature of matter and energy, rather than the large-scale structure of the cosmos. Or perhaps they would have developed entirely different ways of thinking about the universe, ways that we cannot even imagine, shaped by their unique perspective on reality. This is the power of cosmic voids. They challenge us to think beyond our own circumstances. They remind us that our view of the universe is just one view among many possibilities. And they invite us to imagine what reality might look like from a completely different vantage point. Now let us address a question that sometimes arises in discussions of the Boötes Void, particularly in less scientific circles. Could the void be artificial? Could it have been created or modified by an advanced civilization? This idea falls firmly in the realm of speculation, but it is worth considering for what it reveals about both the void and about our own assumptions. The concept of megascale engineering, structures built by civilizations far beyond our own technological capabilities, has a long history in science fiction and speculative thought. The most famous example is the Dyson sphere, a hypothetical structure that completely surrounds a star and captures all of its energy output. Other concepts include ring worlds, artificial habitats circling stars, and even galaxy-spanning constructions. Could the Boötes Void be the result of some unimaginably powerful technology? Could an advanced civilization have somehow cleared out 300 million light-years of space, removing or relocating the matter that should be there? The short answer is almost certainly no. The energies required would be beyond anything we can conceive of. Moving even a single star requires colossal amounts of energy, moving or destroying the thousands of galaxies that should populate the Boötes Void is so far beyond any plausible technology that it belongs in the realm of magic rather than science. Moreover, we have perfectly good natural explanations for the existence of the void. The bubble merger theory, the primordial density variations, the normal processes of cosmic evolution, all of these can account for what we observe without invoking any exotic interventions. But the question itself is interesting for another reason. It reveals our instinctive tendency to look for agency, for intentionality, behind the phenomena we observe. When we see something surprising or unexplained, our first impulse is often to ask who did this? Who is responsible? What intelligence lies behind the pattern? This impulse has served us well in our evolutionary history. Detecting agency, recognizing the intentions of other beings, was crucial for survival on the African savanna. But it can lead us astray when we confront the impersonal vastness of the cosmos. The Boötes Void was not made by anyone. It was not designed or constructed or hollowed out. It simply happened, the result of physical processes operating over billions of years. And in a way that makes it even more remarkable. The universe, without any guiding hand, without any plan or purpose, produced a structure of extraordinary size and emptiness. It produced something that challenges our intuitions, that stretches our imagination, that makes us gasp at its scale. And it did this through nothing more than gravity and time and the random fluctuations of the primordial cosmos. There is a lesson here about the power of natural processes. Given enough time and space, physics alone can create wonders that rival anything we might imagine from intelligent design. The Boötes Void is not the work of cosmic engineers. It is the work of the cosmos itself, sculpting itself into forms both familiar and strange. Let us continue our exploration by looking at how the Boötes Void fits into the larger story of cosmic structure. Because the void does not exist in isolation, it is connected, in subtle but important ways, to everything else in the universe. We have already discussed the cosmic web, that foam-like pattern of filaments and voids that spans billions of light years. But the web is not static. It is constantly evolving, changing, reshaping itself under the influence of gravity and dark energy. In the early universe, the web was barely present. The distribution of matter was nearly uniform, with only tiny variations in density. But as time passed, those variations grew. Denser regions pulled in more matter and became even denser. Less dense regions lost matter and became even emptier. The contrast between peaks and valleys grew more pronounced with every passing million years. This process of gravitational amplification is ongoing. It has not stopped. The filaments are still growing denser. The voids are still growing emptier. The cosmic web is still evolving. And this evolution is not happening at the same rate everywhere. In regions dominated by matter, gravity slows the expansion of space. In regions dominated by emptiness, dark energy accelerates the expansion. Different parts of the universe are effectively aging at different rates, evolving along different trajectories. The Boötes Void, as one of the largest and emptiest regions we know of, is at the leading edge of this cosmic evolution. It represents what the universe will look like in the distant future, when dark energy has had more time to work and the voids have grown even larger. In this sense, studying the Boötes Void is like studying the future. It gives us a preview of coming attractions, a glimpse of the endgame of cosmic structure formation. And that endgame, as we have discussed, is one of increasing isolation and emptiness. But there is another side to this story. While the voids grow, the dense regions grow denser. The filaments may stretch and thin, but the clusters at their nodes continue to accumulate matter. The largest structures in the universe are still forming, still gathering mass, still building themselves up even as the voids expand around them. This creates a striking picture of cosmic evolution. Imagine the universe as a kind of sorting process, where matter is gradually separated from emptiness. The rich get richer, the poor get poorer. The cosmos organizes itself into ever more extreme concentrations and ever more extreme absences. The Boötes Void is the poster child for the emptiness side of this process. But on the opposite end of the spectrum, we find structures like the Shapley supercluster, a massive concentration of galaxies that represents one of the densest regions in the nearby universe. These two extremes, the supervoid and the supercluster, are two sides of the same coin. They are both products of the same gravitational sorting that has been operating since the Big Bang. This brings us to a fundamental question about the nature of the universe. Is the Boötes Void typical or exceptional? Is it a rare outlier, or is it representative of what supervoids generally look like? The answer, as best we can tell, is somewhere in between. The Boötes Void is one of the largest and most well-studied voids, but it is not unique. Other supervoids of comparable size exist, scattered throughout the observable universe. The Eridanus supervoid, for example, may be even larger, though its properties are less well-constrained. What makes the Boötes Void special is not its size alone, but its combination of size, emptiness, and proximity to us. At 700 million light-years, it is close enough to study in detail, yet far enough to encompass a truly enormous volume of space. It offers a natural laboratory for understanding the physics of voids, one that is large enough to reveal the extreme consequences of cosmic emptiness. Scientists have cataloged thousands of voids in the observable universe, ranging from small, underdense regions just tens of millions of light-years across to supervoids spanning hundreds of millions. The distribution of these voids follows statistical patterns that can be predicted from our cosmological models. Most voids are small, large voids are rarer. Supervoids like Boötes are the tail of the distribution, the extreme outliers. But here's the thing about extreme outliers. In a universe as vast as ours, even rare events will occur many times. The observable universe contains hundreds of billions of galaxies spread across tens of billions of light-years. Given that enormous volume, we should expect to find some structures that push against the boundaries of what is probable. The Boötes Void may be one of those structures. It may be a statistical fluctuation, a lucky roll of the cosmic dice that produced an unusually large void in our neighborhood. Or it may be revealing something about the initial conditions of the universe that we do not yet fully understand. Either way, it stands as a reminder that the cosmos is full of surprises. Our models can predict averages and probabilities, but they cannot tell us exactly what we will find in any particular region. The universe retains the ability to astonish us, to present us with phenomena that stretch the limits of what we thought was possible. Let us now turn to the practical aspects of exploring the Boötes Void. If you wanted to visit this cosmic emptiness, what would that journey look like? The center of the Boötes Void is approximately 700 million light-years from Earth. To put that in perspective, light that left the void center when life on Earth was just beginning to colonize the land during the Cambrian period is only now reaching our telescopes. At the fastest speed ever achieved by a human-made object, the Parker Solar Probe's 430,000 miles per hour, it would take about 1 trillion years to reach the center of the Boötes Void. That is roughly 70 times the current age of the universe. Clearly, physically traveling to the void is not something we will ever accomplish. The distances are simply too vast, the energies required too enormous. Even with technologies far beyond our current capabilities, crossing hundreds of millions of light-years remains in the realm of fantasy. But we can explore the void in other ways. We can send light and radio waves into its depths, and we can collect the faint signals that emerge from the other side. We can build mathematical models and computer simulations that recreate the void's structure and evolution. We can, through the power of science and imagination, understand what lies in that distant emptiness without ever setting foot there. And in a sense, that understanding is the real voyage of exploration. The physical journey may be impossible, but the intellectual journey is well underway. Every new observation, every refined model, every theoretical insight brings us closer to truly comprehending the great nothing. There is poetry in this. The Boötes Void is defined by absence, by what is not there. And yet, through the presence of human curiosity and scientific endeavor, it becomes filled with meaning. The emptiness becomes a canvas on which we paint our understanding of the cosmos. Consider for a moment the scientific papers that have been written about the Boötes Void. Hundreds of researchers have devoted portions of their careers to studying this region of space. They have analyzed data, built theories, debated interpretations. The void, empty as it is, has generated a wealth of human thought and effort. In the pages of scientific journals, the Boötes Void is anything but empty. It teems with ideas and hypotheses, with questions and proposed answers. It has inspired creativity and collaboration, sparked debates, and led to discoveries. The great nothing has become paradoxically a source of great intellectual richness. This is one of the beautiful ironies of science. The things we cannot touch or visit or experience directly become, through study and contemplation, intimately familiar. Astronomers who have spent their careers studying the Boötes Void know it in ways that most people never know their own neighborhoods. They understand its structure, its history, its relationship to the cosmos at large. They have made it their own, in a way, through the act of trying to understand it. And this process of understanding transforms not just the void, but us as well. Each discovery about the cosmos changes how we see ourselves. Each new piece of knowledge expands our perspective, challenges our assumptions, invites us to grow. The Boötes Void has played a small but significant role in this ongoing transformation. It has reminded us that the universe is mostly empty. It has shown us that vast structures can form from almost nothing. It has challenged our models and driven us to develop better ones. And it has, through its sheer scale and strangeness, inspired a sense of wonder that is the beating heart of scientific inquiry. Let us take a moment to appreciate just how much we have learned about cosmic voids in the decades since the Boötes Void was discovered. In 1981, voids were still a relatively new concept in astronomy. The cosmic web had only recently been discovered, and our understanding of large-scale structure was in its infancy. Today, voids are recognized as fundamental components of cosmic structure. We have identified thousands of them, mapped their distribution, measured their properties, and developed sophisticated theories to explain their formation and evolution. The study of voids has become a branch of cosmology in its own right, with its own conferences, journals, and research programs. This progress has been driven in large part by advances in technology. Modern redshift surveys can measure the positions of millions of galaxies, building three-dimensional maps of the universe that would have seemed like science fiction a generation ago. Computer simulations can model the evolution of billions of particles over cosmic time, creating virtual universes that can be compared against observations. Space telescopes have opened new windows on the cosmos, revealing features that ground-based instruments cannot see. But technology alone does not drive scientific progress. Human creativity and insight are equally essential. The scientists who study voids have developed clever new techniques for identifying and characterizing these structures. They have proposed bold new theories to explain the observations. They have asked questions that no one had thought to ask before. This combination of technological capability and human ingenuity has brought us to a remarkable place. We now understand the basics of how voids form and evolve. We know that they arise from primordial density fluctuations, grow through gravitational dynamics, and are shaped by dark energy. We can predict their statistical properties and match those predictions against observations, but significant mysteries remain. The exact mechanisms that determine void sizes and shapes are still being debated. The role of dark energy in void evolution is not fully understood. The relationship between voids and the galaxies they contain raises questions that do not yet have clear answers. The Boötes Void, as one of the largest and best-studied examples, sits at the center of many of these debates. It is a test case for our theories, a benchmark against which we can measure our understanding. If we can explain the Boötes Void, we can probably explain voids in general. If we cannot, it tells us that something is missing from our picture of the cosmos. Let us turn now to one of the most profound implications of the Boötes Void: what it tells us about the nature of space itself. In everyday experience, space seems like a passive backdrop against which events unfold. Objects move through space, but space itself does nothing. It is simply there, a neutral container for the things that actually matter. But this everyday intuition is wrong. Space, according to modern physics, is anything but passive. It can curve and stretch. It can expand and contract. It can be shaped by matter and energy, and it can in turn influence how matter and energy behave. The Boötes Void is a vivid illustration of this dynamic nature of space. Within the void, space is expanding faster than in the denser regions that surround it. The void is not just empty of matter, it is a region where the very fabric of space-time behaves differently. This difference in behavior has real, measurable consequences. Light passing through the void loses a tiny bit of energy because of the expansion. Hypothetical observers within the void would measure time and distance slightly differently than we do. The void is not just a gap in the distribution of matter, it is a region with its own physical properties, distinct from the rest of the cosmos. This perspective transforms how we think about emptiness. The Boötes Void is not simply nothing, it is a something, a region with its own characteristics and behaviors. It is not the absence of existence, but a form of existence in its own right. This is a deep and subtle point that deserves more attention. We tend to think of existence in terms of stuff, in terms of particles and objects and things you can touch. But modern physics tells us that space itself exists. It has properties. It can be measured and described. The Boötes Void is not a hole in reality. It is a particular state of reality, one characterized by low density and rapid expansion. In this light, the name Great Nothing seems almost misleading. Yes, the void is nearly empty of matter, but it is full of space, full of the fabric of the universe itself. And that fabric is doing things, expanding and evolving and interacting with the matter that does exist. The void is anything but inactive. This reconceptualization of emptiness has implications far beyond cosmology. It touches on fundamental questions about the nature of existence and reality. What does it mean for something to exist? Is emptiness a thing or the absence of things? How do we understand a universe that is mostly empty yet filled with space? These are philosophical questions as much as scientific ones. The Boötes Void does not provide definitive answers, but it forces us to confront the questions with fresh eyes. It challenges our intuitions and invites us to think more deeply about the nature of the cosmos. And perhaps that is the greatest gift of the Boötes Void. Not any specific discovery or insight, but the way it pushes us to expand our thinking. It takes us beyond the comfortable and familiar into realms where our everyday understanding breaks down and something new must be constructed. This is the essence of scientific exploration. Not just accumulating facts, but transforming how we see the world. The Boötes Void, in its vast emptiness, has done exactly that. It has changed how astronomers think about the universe. It has opened new avenues of research and inquiry. It has, in its own quiet way, expanded the boundaries of human knowledge, and the exploration is far from over. Every year brings new observations, new data, new opportunities to refine our understanding. The telescopes that will come online in the coming decades will probe the void with unprecedented precision. The simulations that will run on future supercomputers will model its evolution with exquisite detail. We are still in the early chapters of our relationship with the Boötes Void. The story is unfolding, and the most surprising revelations may still lie ahead. Now we approach the climax of our journey. We have explored the discovery of the Boötes Void, its physical properties, its place in cosmic structure, and its implications for our understanding of the universe. We have considered hypothetical civilizations that might live within it, and speculated about artificial origins. We have examined the practical challenges of studying something defined by emptiness, and reflected on what the void tells us about the nature of space itself. But there is one more question we must confront, perhaps the deepest question of all. Why does the Boötes Void matter? Not in the scientific sense. We have discussed at length why the void is interesting to astronomers and cosmologists, but why should it matter to you sitting here listening to these words? Why should a patch of empty space 700 million light years away have any significance for your life? The answer, I believe, lies in perspective. The Boötes Void matters because it changes how we see everything else. We live our lives embedded in the small and the immediate. Our concerns are local, personal, tied to the handful of years we spend on this particular planet. From this vantage point, the universe can seem distant and irrelevant, a backdrop of pretty lights that has nothing to do with our daily struggles and joys. But the Boötes Void reminds us that we are part of something incomprehensibly vast. We are connected to a cosmos that contains structures spanning hundreds of millions of light years. We emerge from processes that began in the first moments after the Big Bang and are still unfolding today. We are not separate from the universe, we are expressions of it. And the Boötes Void shows us just how improbable our existence actually is. In a cosmos that is 80% empty, we happen to live in a region dense enough to form stars and planets and life. We are the exceptions, the rare instances where matter has clumped together sufficiently to create complexity and awareness. This is not a reason for pride, but for gratitude. We could so easily have not existed. In the vast majority of the universe, we do not exist. The Boötes Void and the countless other voids scattered throughout the cosmos are reminders of all the places where nothing like us will ever arise. Every atom in your body was forged in the heart of a star, or in the cataclysmic explosion of a supernova. Every element that makes up your flesh and blood was created through cosmic processes spanning billions of years. You are made of star stuff, as Carl Sagan famously observed, but you are also made of luck. The luck of being born in a region of the universe where star stuff could come together and become alive. The Boötes Void represents everything we are not. It is the road not taken, the possibility that never materialized. In its emptiness, we see reflected the fullness of our own existence. There is something almost spiritual about this contemplation, not religious in any doctrinal sense, but spiritual in the sense of connecting us to something larger than ourselves. The Boötes Void inspires awe, that mixture of wonder and humility that comes from confronting the truly immense. And awe, I would argue, is precisely what we need more of in our lives. In an age dominated by small screens and immediate gratifications, we can lose sight of the big picture. We can forget that we are participants in a cosmic drama that has been unfolding for 14 billion years and will continue for billions more. The Boötes Void calls us back to that big picture. It says, look up, look out. Remember how small you are and how miraculous. Remember that you are standing on a small rock orbiting an ordinary star in a galaxy of hundreds of billions of stars, in a universe of hundreds of billions of galaxies, most of which are separated by voids of unimaginable emptiness. Remember and be grateful. Remember and be humble. Remember and be curious about all the things you have yet to learn. This is why the Boötes Void matters. Not because it will help you balance your checkbook or advance your career, but because it can change how you see yourself and your place in the cosmos. It can expand your mind, lift your vision, remind you of the wonder that surrounds us always, if only we have eyes to see it. And now we come to the heart of the mystery, the question that has driven astronomers to study the Boötes Void for over 4 decades, the puzzle that still lacks a definitive answer. How did such an enormous void form in the first place? We have touched on this question throughout our journey, but now let us confront it directly. Let us lay out the competing theories, examine the evidence, and consider what the existence of the Boötes Void ultimately means for our understanding of cosmic evolution. The standard model of cosmology, the framework that has guided our understanding of the universe for decades, makes specific predictions about the sizes of voids. These predictions are based on the physics of gravitational collapse, the age of the universe, and the statistical properties of the primordial density fluctuations. According to this model, voids should rarely exceed about 200 million light-years in diameter. The gravitational processes that create voids work slowly. Matter needs time to drain from underdense regions into denser ones, and the universe is only 14 billion years old. Given that time constraint, there is a limit to how large and how empty a void can become. The Boötes Void, with its diameter of 330 million light-years, pushes against this limit. It is not impossible within the standard model, but it is improbable. It represents an extreme outlier, a rare fluctuation in the cosmic dice. This improbability has led some scientists to question whether our standard model is complete. Perhaps there are physical processes we do not fully understand. Perhaps the initial conditions of the universe were different from what we assume. Perhaps dark energy behaves in ways that enhance void growth beyond what our current equations predict. These are not fringe ideas. They are serious scientific hypotheses, actively debated in the literature. The Boötes Void, by its very existence, is pushing the boundaries of cosmological theory. Let us examine the leading explanations more closely. The bubble merger theory, as we discussed earlier, proposes that the Boötes Void formed from the coalescence of multiple smaller voids. This is perhaps the most conservative explanation, requiring no new physics beyond what we already understand. The idea is straightforward. In the early universe, the cosmic web began to form with many small voids scattered throughout. As time passed, adjacent voids grew and eventually merged, their separating walls thinning and dissolving. Just as soap bubbles and foam can combine to form larger bubbles, cosmic voids can combine to form supervoids. This process would explain several features of the Boötes Void. The tube-shaped distribution of galaxies through the middle could be the remnant of a wall that once separated two or more merging voids. The overall size could be the accumulated result of several merger events over cosmic history. Computer simulations support this picture. When cosmologists model the evolution of the universe on supercomputers, they see voids merging and growing over time. Some of these simulated voids reach sizes comparable to the Boötes Void, though they remain rare. The bubble merger theory is attractive because it requires nothing exotic. It works within the established framework of cosmology. But it raises its own questions. Why did so many voids form in the same region to begin with? Was it just chance, or was there something special about this part of the universe? An alternative explanation focuses on the primordial conditions. Perhaps the region that would become the Boötes Void started with an unusually large deficit of matter, a cosmic low point in the initial density field. We know that the early universe had density fluctuations. These fluctuations followed a statistical pattern known as a Gaussian distribution. Most regions had densities close to the average. A few had significantly more or less. In a Gaussian distribution, extreme outliers are rare but not impossible. A region 3 or 4 standard deviations below average would be extraordinarily underdense, and when gravity amplified this underdensity over cosmic time, it could produce a supervoid. The Boötes Void might be such an outlier, a statistical fluctuation that happened to land in our observable universe, a rare but natural product of random chance. This explanation has the virtue of simplicity. It does not require any new physics or unusual processes. It just requires that we happen to be close enough to an extreme fluctuation to observe it. But simplicity can be a weakness as well as a strength. If the Boötes Void is just a statistical fluke, it tells us nothing new about the universe. It is like rolling double sixes. Unusual, but not fundamentally interesting. Some scientists are not satisfied with this. They see in the Boötes Void an opportunity to probe deeper questions about cosmology. One intriguing possibility involves dark energy. This mysterious force, which drives the accelerated expansion of the universe, is still poorly understood. We know its effects, but we do not know its nature. Different theories of dark energy make different predictions about how it behaves in different environments. In particular, some theories suggest that dark energy might be stronger in voids than in dense regions. If matter suppresses dark energy in some way, then the emptiness of a void would allow dark energy to operate more freely. Voids would expand faster than expected, growing to larger sizes than the standard model predicts. This is speculative, but it is testable. Precise measurements of void properties, combined with observations of how the universe is expanding, could reveal whether dark energy behaves differently in different environments. The Boötes Void, as one of the largest voids we can study, is a prime target for such investigations. Another possibility involves modifications to our theory of gravity. Einstein's general relativity has been extraordinarily successful at explaining gravitational phenomena on scales from the solar system to the cosmic web, but there are hints that it might not be the complete story. Alternative theories of gravity, such as modified Newtonian dynamics or various extensions of general relativity, make different predictions about the formation and evolution of cosmic structures. Some of these alternatives predict larger voids than the standard model. If one of these theories is correct, the Boötes Void might be evidence for new gravitational physics. Again, this is speculative. General relativity has passed every test we have thrown at it. But science advances by testing ideas against observations, and the Boötes Void provides a unique testing ground. There are even more exotic possibilities. Some researchers have wondered whether the Boötes Void could be connected to the idea of a multiverse, a hypothetical ensemble of universes with different properties. If our universe is just one bubble in a vast foam of universes, perhaps interactions between bubbles could create unusual features in the cosmic structure. This idea is highly speculative, verging on the unprovable, but it illustrates how far-reaching the implications of the Boötes Void could be. If the void cannot be explained by conventional physics, it might be pointing us towards something fundamentally new about the nature of reality. Where does the evidence point? What is the most likely explanation for the Boötes Void? The honest answer is that we do not know for certain. The data are consistent with the conservative explanations. The bubble merger theory and the primordial fluctuation theory can both account for what we observe. We have no definitive evidence that requires new physics. But the data are also consistent with more exotic possibilities. We cannot rule out that dark energy behaves unusually in voids, or that gravity deviates from general relativity on large scales, or that some unknown process contributed to the void's formation. This uncertainty is not a failure of science. It is the normal state of affairs at the frontier of knowledge. We are still gathering data, still refining our models, still developing new ways to probe the mysteries of the cosmos. The coming decades will bring tremendous advances in our ability to study voids. New telescopes will map the universe with unprecedented precision. New surveys will catalog millions of galaxies, revealing the fine structure of the cosmic web. New theoretical tools will allow us to make sharper predictions and more stringent tests. Within our lifetimes, we may have a definitive answer to the question of how the Boötes Void formed. Or we may discover that the question leads to even deeper mysteries, ones we cannot yet imagine. Either outcome would be a victory for human curiosity. Science is not about finding final answers. It is about the endless pursuit of understanding, the perpetual journey into the unknown. The Boötes Void is one stop on that journey, one mystery among the countless mysteries that make the universe worth exploring. Let me now offer my own perspective on what the Boötes Void means. This is not the consensus view of scientists. It is a personal reflection shaped by years of contemplating the cosmos and our place in it. I believe the Boötes Void is a reminder of humility. It shows us how much we still do not know. Despite all our advances, despite the sophisticated telescopes and powerful computers, we cannot fully explain why this vast emptiness exists. We have theories and hypotheses, but we lack certainty. This humility is healthy. It protects us from the arrogance of thinking we have figured everything out. It keeps us curious, open-minded, ready to be surprised. The Boötes Void, like all great mysteries, teaches us that the universe is larger and stranger than our current understanding can contain. I also believe the Boötes Void is a source of wonder. Not wonder in the vague, feel-good sense, but wonder in the deep, unsettling sense. The kind of wonder that makes you lie awake at night, staring at the ceiling, trying to wrap your mind around something too big to comprehend. 330 million light years of nearly perfect emptiness. That is something to wonder at. That is something that defies imagination, that stretches the mind to its limits. And that stretching, that reaching beyond what we can easily grasp, is one of the most valuable things a human being can do. Finally, I believe the Boötes Void is an invitation to explore, to question, to push beyond the boundaries of current knowledge. It says to us, there is more to discover. There are still surprises waiting in the darkness. Do not be satisfied with what you know. Keep looking, keep asking, keep wondering. This invitation is extended to everyone, not just professional scientists. You do not need a degree in astronomy to contemplate the Boötes Void. You do not need a telescope to feel its implications. All you need is the willingness to look up and think big. The universe belongs to all of us. Its mysteries are our shared inheritance. And the Boötes Void, that great hole in the fabric of the cosmos, is part of our common story. Let us now bring our journey to a close. We have traveled a long way together, from the discovery of the void in 1981 to the cutting-edge research of today. We have explored scales of distance that dwarf anything in ordinary experience. We have confronted questions that touch on the deepest nature of reality. What have we learned? We have learned that the universe is not filled with matter, as our everyday intuition might suggest. It is filled with emptiness, with vast regions of nearly nothing stretching between the bright islands of galaxies. The Boötes Void is the largest known example of this cosmic emptiness, but it is far from unique. Voids dominate the volume of the universe, and they are growing larger with every passing moment. We have learned that the Boötes Void challenges our understanding of cosmic evolution. Its size and emptiness push against the predictions of our best models. While the void can be explained within the standard framework of cosmology, it does so only by invoking rare statistical fluctuations or merger events. The possibility remains that something more is at play, something our current theories do not fully capture. We have learned about the galaxies that inhabit the void. Those 60 lonely worlds clustered in a strange tube through the middle of the emptiness are among the most isolated structures in this universe. They have evolved in cosmic solitude, untouched by the interactions that shape galaxies in denser environments. They offer unique insights into what galaxy evolution looks like without outside interference. We have learned about dark energy and its relationship to voids. In these empty regions where matter is scarce and gravity weak, dark energy reigns supreme. The voids are laboratories for studying this mysterious force, and the Boötes Void is one of the largest such laboratories available to us. We have learned, or perhaps been reminded, of our own cosmic insignificance. The Boötes Void is so large that it defies comprehension. It reduces our entire galaxy, our entire local group, our entire supercluster to mere specks. And yet this humbling perspective is also liberating. It frees us from the illusion that we are the center of everything and invites us to see ourselves as participants in a much grander drama. And we have learned that the universe still has the power to surprise us. After decades of study, the Boötes Void retains its mysteries. We do not fully understand why it exists. We do not know what its existence implies for the future of cosmic structure. We are still in the middle of the story, still learning, still discovering. This is where science leaves us, not with final answers, but with better questions. Not with certainty, but with informed wonder. The Boötes Void is not a closed book. It is an open invitation to keep reading, keep exploring, keep pushing the boundaries of what we know. As we close this exploration, I want to leave you with a thought, a perspective to carry with you as you return to your daily life. The night sky you see when you look up contains wonders beyond measure. Every point of light is a sun, many of them with planets of their own. Every hazy smudge is a galaxy, home to billions of stars. And between those points of light, in the darkness that dominates the view, there are voids, regions of cosmic emptiness that span distances we can barely imagine. The Boötes Void is out there right now, in the direction of the constellation Boötes. You cannot see it with your eyes. It is too far away and too empty to produce any visible signal. But you can know it is there. You can hold in your mind the image of that vast emptiness, that 330 million light years of almost nothing. And in knowing it is there, you become connected to it. The same universe that produced the Boötes Void produced you. The same physical laws that govern its expansion govern your heartbeat. You are made of matter that was once scattered across cosmic space, and when you die, that matter will return to the cosmos, perhaps one day, to find its way into a void of its own. We are all stardust, as the saying goes, but we are also void dust. We are part of a universe that is mostly empty, and that emptiness is as much a part of our heritage as the stars. The Boötes Void reminds us of this. It reminds us that existence is fragile and improbable, a thin film of complexity stretched across an ocean of nothing. It reminds us that we are lucky to be here, lucky to be alive, lucky to be aware of the cosmos that contains us. So go outside tonight, if the weather permits. Look up at the stars. Find the constellation Boötes if you can, that ancient pattern of the herdsman standing watch over the northern sky. And remember that behind those stars, far beyond anything your eyes can see, there is a hole, a vast emptiness, the great nothing. And remember that you are one of the fortunate ones. You exist on the side of existence, not the side of absence. You live in a region where matter has gathered, where stars have formed, where planets have coalesced, where life has emerged. You are part of the rare 20%, the cosmic exception, the improbable miracle. That is what the Boötes Void teaches us. Not just facts about astronomy, but wisdom about existence. Not just data about the universe, but perspective on what it means to be alive. Thank you for joining me on this journey into the great nothing. I hope you have found it as fascinating and thought-provoking as I have. The cosmos is full of wonders, and the Boötes Void is among the most awe-inspiring of them all. If you have enjoyed this exploration, I hope you will continue to look up and wonder. The universe has so much more to reveal, so many more mysteries waiting to be discovered. Every star, every galaxy, every void has a story to tell. And the story of our universe is still being written. If you found value in this journey, please consider subscribing to join us on future explorations. Hit that like button if the Boötes Void has expanded your understanding of the cosmos. And drop a comment below sharing your thoughts on what it would be like to live in such cosmic isolation, or what aspect of the void fascinates you most. Until next time, keep looking up. The universe is waiting. But before we truly conclude, there are still more facets of this cosmic wonder to explore. The story of the Boötes Void interweaves with some of the most profound questions humanity has ever asked. Questions about time, about space, about the nature of existence itself. Let us delve deeper into these connections. Consider the relationship between the Boötes Void and time. When we look at the void, we are not seeing it as it exists right now. We are seeing it as it existed 700 million years ago. That is how long the light has taken to travel from the void center to our telescopes. 700 million years. When that light left the center of the Boötes Void and began its journey toward Earth, our planet was very different. Complex life had not yet evolved. The continents were arranged in unfamiliar patterns. The atmosphere had a different composition. Our world was alien, unrecognizable, still in the early stages of its biological revolution. Everything you have ever known, every civilization that has risen and fallen, every species that has evolved and gone extinct, every human thought and dream and achievement, all of it has happened during the time it took that light to reach us. The light that left the Boötes Void 700 million years ago has witnessed, in a sense, the entire history of complex life on Earth, and the void has changed during that time. 700 million years is not a trivial span, even on cosmic timescales. Galaxies have moved, stars have formed and died. The void itself has grown, expanded by dark energy, pushed against its boundaries by the relentless force that is accelerating the universe. The Boötes Void we observe is a snapshot of the past. The void that exists right now at this very moment is different, larger, emptier, more evolved, but we cannot see it. We cannot know what it looks like today. The speed of light sets an absolute limit on how quickly information can travel, and that limit means we are forever looking backward in time when we look outward in space. This is a profound truth that the Boötes Void helps illuminate. Our view of the universe is inherently historical. We do not see the cosmos as it is, we see it as it was. And the farther we look, the further back in time we see. When astronomers observe galaxies at the edge of the observable universe, they are seeing them as they were more than 13 billion years ago when the universe itself was young. Those galaxies have long since evolved, merged, transformed into something unrecognizable. Some of them may no longer exist. But we cannot know because the light showing us their current state has not had time to reach us. The Boötes Void sits at an intermediate distance, close enough to study in detail but far enough to remind us of this temporal disconnect. It is a window into the past, showing us what that region of the universe looked like when trilobites were still hundreds of millions of years in Earth's future. Now let us consider another dimension of the void's significance, its relationship to the concept of structure itself. We tend to think of structure as something made of stuff. A building is made of bricks and steel. A tree is made of wood and leaves. Even abstract structures like social organizations or mathematical patterns are usually described in terms of their components. But the Boötes Void challenges this assumption. It is a structure made of absence. Its defining feature is what it lacks, not what it contains. The void has boundaries, shape, properties that can be measured and described. It is as real as any galaxy or cluster, and yet it is fundamentally empty. This inverts our usual way of thinking about reality. We focus on the positive, on what exists, but the Boötes Void reminds us that absence can be just as structured, just as significant, just as real as presence. Consider an analogy from everyday life. A hole in a piece of paper is defined by the paper around it. The hole itself contains nothing but air. And yet we recognize the hole as a thing. We can describe its size and shape. We can point to it and say, there is a hole. The hole has existence, even though it is made of nothing. The Boötes Void is like that hole, but on a cosmic scale. It is defined by the galaxies and superclusters that surround it. It contains almost nothing but empty space, and yet it is one of the most significant structures in the observable universe. This perspective has implications beyond astronomy. It suggests that we should pay more attention to absences, gaps, and voids in all areas of life. The spaces between things can be just as important as the things themselves. What is missing can be just as significant as what is present. Let us also explore the connection between the Boötes Void and the arrow of time. The second law of thermodynamics tells us that entropy, the measure of disorder in a system, tends to increase over time. Systems evolve from ordered states to disordered states. Ice melts, rooms get messy, the universe winds down. This increase in entropy is what gives time its direction. The past is different from the future because the past had lower entropy. We remember the past but not the future because memories are records of lower entropy states. The arrow of time points from order to disorder, but the Boötes Void seems to complicate this picture. In some sense, a void is more ordered than a random distribution of galaxies. A perfectly empty region is maximally uniform, maximally featureless, maximally simple. It has low entropy in the sense that there is only one way to be perfectly empty, but many ways to have various distributions of matter. And yet voids are the end state of cosmic evolution, at least in certain regions. As dark energy continues to drive expansion, voids will grow and eventually dominate the universe. Matter will concentrate into ever smaller islands, while the spaces between them expand into infinite emptiness. Is this increasing emptiness a form of increasing order, or is it a form of increasing disorder? The answer is subtle and depends on how you define your terms. What is clear is that the Boötes Void represents an advanced stage of cosmic evolution. It has had billions of years to develop, billions of years for matter to drain away and emptiness to grow. In this sense, it is older than the dense regions that surround it, more evolved, further along the path that all regions will eventually travel. Looking at the Boötes Void is like looking at the future, not just the future of that particular region, but the future of the entire universe. In time, vast emptiness will be the rule, not the exception. The cosmic web will dissolve, galaxies will drift apart, the voids will win. There is something melancholy about this vision. The universe we know, with its rich structure and complex patterns, is temporary. It is a passing phase, a brief flowering, of order before the long night of emptiness. The Boötes Void is a reminder that this flowering will not last forever. But there is also something liberating about it. If the universe is destined for emptiness, then our current existence is all the more precious. We are living in a special time, a time when complexity is possible, when stars shine and planets form and life can evolve. We should cherish this time, make the most of it, appreciate its improbable beauty. The Boötes Void teaches us to value what we have. By showing us what the universe will become, it helps us appreciate what it currently is. Now let us turn to another profound connection. The relationship between the Boötes Void and consciousness. We have discussed hypothetical civilizations living within the void, cut off from the wider universe, by hundreds of millions of light years of emptiness. But there is a deeper question here. What does the existence of the Boötes Void imply about the nature of consciousness itself? Consciousness, as we understand it, arises from matter. It emerges from the interactions of neurons in brains, from the complex information processing that biological systems perform. Without matter, there can be no consciousness. The void, nearly empty of matter, is also nearly empty of the potential for awareness. This connects to the anthropic principle, the observation that the universe must have the properties necessary to produce observers like us, because otherwise we would not be here to observe it. We cannot find ourselves in a universe hostile to consciousness. We can only exist in regions where the conditions are right for complexity to emerge. The Boötes Void is a reminder that most of the universe is not right for complexity. Most of the universe is too empty, too diffuse, too hostile to the emergence of anything interesting. We exist in a special place, a rare island of density where matter has gathered sufficiently to form stars and planets and minds. If consciousness requires matter, and matter is mostly absent from the universe, then consciousness is a rare phenomenon. It emerges only in special places against tremendous odds. The Boötes Void, by its emptiness, highlights how rare and precious our existence really is. But there is another perspective to consider. Some philosophers and scientists have speculated about forms of consciousness very different from our own. Could there be awareness without matter? Could the vacuum of space itself be conscious in some strange and alien way? These ideas are highly speculative, beyond the reach of current science. But the Boötes Void invites such speculation. When you contemplate a region of nearly perfect emptiness spanning hundreds of millions of light years, you cannot help but wonder what might be happening there. Is it truly dead and lifeless? Or could there be some form of existence we cannot imagine playing out in the darkness? We have no way to answer these questions, but asking them is itself valuable. It stretches our imagination, challenges our assumptions, opens us to possibilities we might otherwise overlook. The Boötes Void is a teacher in this way. It teaches us to question, to wonder, to remain humble about the limits of our understanding. We think we know what existence requires. We think we know what consciousness needs. But the universe is vast and strange, and it may contain surprises we cannot anticipate. Let us also consider the aesthetic dimension of the Boötes Void. There is a beauty to this cosmic emptiness that goes beyond scientific interest. It has the stark, austere beauty of a desert landscape or a minimalist painting. In art, negative space is as important as positive space. A painting is not just about the objects depicted, it is also about the spaces between them, the areas of emptiness that give the composition balance and breathing room. The greatest artists understand this. They know that what is left out is as important as what is included. The universe, in creating the Boötes Void, has created a masterpiece of negative space. It has left out 330 million light-years of matter, and in doing so has created something striking and memorable. Time, quans. The void draws the eye precisely because it is empty. It stands out against the crowded background of the cosmic web. This aesthetic appreciation is not frivolous. It is part of how we relate to the universe, how we find meaning in the cosmos. Scientists are sometimes reluctant to talk about beauty as if it were somehow unscientific. But beauty motivates exploration. It draws us towards certain phenomena and away from others. The beauty of the Boötes Void has captured the imagination of astronomers for decades, driving research and inspiring wonder. There is also a sublime quality to the void. The sublime, in the philosophical sense, is the combination of beauty and terror, attraction and awe. It is the feeling you get standing at the edge of a great canyon or watching a powerful storm. You are attracted by the beauty, but also humbled by the power, the vastness, the indifference of nature. The Boötes Void evokes this sublime feeling. It is beautiful in its stark emptiness, but it is also terrifying in its scale. The human mind cannot really grasp 330 million light-years of nothing. We can say the words, we can write the numbers, but we cannot truly feel what they mean. The void is beyond us, above us, utterly indifferent to our existence. And yet we keep trying to understand it. We keep building telescopes and writing equations and telling stories about this vast emptiness. That effort, that persistence, is one of the most admirable things about our species. Faced with the incomprehensible, we do not give up. We keep reaching, keep questioning, keep pushing the boundaries of understanding. The Boötes Void has been a companion on this journey of human curiosity. It has been there, waiting in the darkness, for as long as the cosmos has existed. And when Robert Kirshner and his colleagues first mapped its boundaries in 1981, they added it to the catalog of human knowledge. They gave a name to something that had been nameless for billions of years. There is power in naming. When we name something, we claim it in a sense. We bring it into the realm of human understanding, human conversation, human meaning. The Boötes Void now belongs to us, not in any legal or physical sense, but in the deeper sense of being part of our story. And what a story it is. The story of a species that arose on a small planet orbiting an ordinary star, in an ordinary galaxy, a species that looked up at the night sky and wondered what was out there, a species that built tools to extend its vision, to see farther and clearer than nature ever intended. a species that discovered against all odds that it was part of a vast cosmic web, and that this web contained holes, great empty spaces where almost nothing existed. The Boötes Void is now part of this story. It is woven into the tapestry of human knowledge, connected to everything else we have learned about the universe. And as long as humans continue to exist, continue to wonder, continue to explore, the void will remain part of our heritage. This is perhaps the ultimate meaning of the Boötes Void. Not any particular scientific fact or discovery, but its place in the human story. It is one of the landmarks we have encountered on our journey of exploration. One of the wonders that has made us stop and stare and reconsider our assumptions. The journey continues. The Boötes Void is not the final destination. It is one stop among many on an endless voyage of discovery. There are more voids to find, more mysteries to solve, more wonders to contemplate. The universe is inexhaustible, and so is human curiosity. So let us carry the Boötes Void with us as we continue forward. Let it remind us of the vastness of existence, the rarity of complexity, the preciousness of awareness. Let it humble us and inspire us and fill us with wonder. The great nothing is out there, waiting in the darkness, and we, the fortunate ones, are here to know about it. That is a privilege worth celebrating. That is a story worth telling. Thank you for traveling with me through the emptiness. May your journey through the cosmos continue wherever it leads. If you have made it this far, I truly appreciate you spending this time exploring the mysteries of the universe with me. Please like and subscribe if you want to continue this journey together, and leave a comment sharing what aspect of the Boötes Void captured your imagination most. Was it the sheer scale of the emptiness, the lonely galaxies drifting through the darkness, or perhaps the philosophical questions about existence and consciousness? Whatever sparked your curiosity, hold on to that spark. The universe is full of wonders waiting to be discovered, and curiosity is the key that unlocks them all. Until we meet again among the stars, keep looking up, keep wondering, keep exploring. The cosmos is vast, and you are part of it. There is one final thread we should follow before our journey truly concludes: the connection between the Boötes Void and the question of meaning itself. When we contemplate something as vast and empty as the Boötes Void, it is natural to wonder about meaning. What is the point of all this emptiness? What is the significance of 330 million light years of almost nothing? In one sense, there is no point. The Boötes Void simply exists, a consequence of physical processes playing out over cosmic time. It was not created for a purpose. It serves no function. It just is. But meaning is not something that exists independently of minds. Meaning is something we create, something we bring to the phenomena we observe. And when we contemplate the Boötes Void, when we study it and wonder about it and tell stories about it, we are creating meaning. The void becomes meaningful because we make it so. Our curiosity transforms empty space into an object of fascination. Our science transforms cosmic absence into a subject of investigation. Our imagination transforms a region of nothing into a source of wonder and reflection. This is the power of consciousness. We take the raw material of the universe, whether stars or voids or anything in between, and we weave it into patterns of significance. We create narratives and theories and poems and music, all from the same underlying reality that would otherwise be meaningless. The Boötes Void in its emptiness is waiting for us to fill it with meaning. Not physically, of course. We will never colonize the void or build structures there. But mentally, spiritually, imaginatively, we can make the void our own. We can turn the great nothing into a great something, a source of insight and inspiration that enriches our lives. This is perhaps the deepest lesson of our journey. The universe does not come with meaning pre-installed. Meaning is something we must create, moment by moment, through the choices we make about where to direct our attention and how to interpret what we find. The Boötes Void could be just empty space. Or it could be a profound teacher, a cosmic mirror reflecting back questions about existence and consciousness and our place in the scheme of things. The difference lies not in the void itself, but in us. I choose to see the Boötes Void as meaningful. I choose to find in its emptiness a source of wonder and a prompt for reflection. And I hope that by sharing this journey with you, I have helped you see it that way too. The universe is stranger and more beautiful than we can imagine. And the Boötes Void, that great hole in the fabric of existence, is one of its most striking features. May it inspire you to keep asking questions, keep seeking understanding, keep finding meaning in the vast and wonderful cosmos we call home. The night sky awaits. The stars are calling. And somewhere out there, in the direction of the constellation Boötes, 330 million light-years of darkness stretches toward infinity. Remember the great nothing, remember what it teaches us, and never stop wondering. The journey ends here, but another always begins. Every conclusion is also a starting point. Every answer opens new questions. That is the nature of exploration, and it is why the human adventure never truly ends. So as we part ways for now, carry the Boötes Void with you. Let it be a companion on your own journey of discovery, whatever form that journey takes. Let it remind you of the vastness that surrounds us and the privilege of being aware of it. And the next time you look up at the stars, take a moment to think about what lies between them. Not just the visible lights, but the invisible darkness. Not just the matter, but the void. Because in that darkness, in that emptiness, there are wonders waiting to be discovered. There are mysteries waiting to be solved. There are meanings waiting to be created. The Boötes Void is out there. And now, in some small way, it is also within you. Thank you for listening. I hope this exploration has expanded your understanding and sparked your imagination. If it has, please show your support by liking this video, subscribing to the channel, and sharing your thoughts in the comments below. What aspect of the Boötes Void fascinated you most? What questions did it raise in your mind? Until next time, keep exploring, keep questioning, keep looking up at the stars and wondering what secrets they hold. The universe is waiting to be understood, and you are part of that grand adventure. Farewell for now, fellow travelers through the cosmos. May your journey be filled with wonder.